Just a minute. Give me a second. I'm going to leave you on the phone, okay? Let's try it now. So
We hear you.
Wonderful.
You're audible.
Okay, so give me a few seconds just to shut down a bunch of extraneous junk here so that I don't have all these other things open at the same time.
Okay.
Make it easier.
Let me kind of start the meeting, and then I'll unmute you. Does that sound good?
Wonderful. Okay.
Okay, just a sec. All right, guys. Looks like we're filling up here. Thank you guys for coming and attending this event. This is the first of a series of events we're going to have throughout the year, probably one a quarter. We don't know what this series is going to be called, but we have a lot of experts in the community, and we felt like, well, why not have each one of them talk on their specific expertise throughout the year? And Jerome is doing our first kickoff presentation. So we're excited to have this presentation. Thank you for coming. I wanted to tell you a little bit about Jerome first. Let me just highlight some of the experience he's had. He's got a degree in electrical engineering from Johns Hopkins University and a PhD in computer science from the University of Utah. He's been a software developer. He's been a research investigator. He's an NSF-funded fellow and has been an instructor at the University of Utah School of Medicine. He has been a president and CEO and still is of Cognitech Corporation, and he's been a board member. So he's had a lot of experience. And I remember when I first met him, I was struck by his experience with like the kind of deep machine learning kind of technologies and the math behind them. But also I was surprised that he had all this experience with contracts and business and that kind of stuff as well. So he brings a lot to the table. He's like an expert in a lot of things, and they seem to intersect very nicely as far as, helpful to Satori. And so anyway, I wanted to introduce him. At the end of his presentation, we will kind of open it up to anybody who wants to ask questions or whatever. And if you can remember, when you do, just try to introduce yourself. Just say, hey, I'm so-and-so. Maybe if you're from an organization, because I know we have people outside of just the Satori community watching this talk and everything. If you're from an organization, or just tell us where you're from, and also kind of explain maybe what interests you have in Satori. Just as, a real quick, like, I'm interested in Satori for this reason. I think it's got potential over in this domain. Or if you're just interested in the talk he gave, maybe list like why that's what you found the most interesting or whatever. So anyway, without further ado, let me unmute Dr. Jerome Soller, and we'll give him the floor.
Just give me a few seconds here. I'm going to try to share my screen. So first, before I try to share my screen, can you hear me?
Yes, we can hear you.
Okay, and there might be a pause at one point for about 2 minutes where I have a a professor that's in the humanities and deals with art, and she wants to attend the talk. And if she's having trouble connecting, I may have her call my cell phone directly and just take a few minutes so she can hear it, just because she was very excited about it. So she's out of a California university. So that's why I'm just taking a few seconds now, is to see if I can get her set up. But if I can't, we'll just get rolling. But my phone does not want to cooperate. Let's see. Okay, so I'll check that in a few minutes, and we'll get rolling. So the first thing I want to do here is I'm just going to set up my own presentation in slide mode, and see if it'll just take me a minute to do this. Let's see. Just hang on. I may just move this camera a little bit so I can see what's going on. Okay. Okay, do you still see my face at this point?
Yep.
Okay. So what I'm going to do is I'm going to share my screen, then I'm going to jump back, and then we'll get rolling on this. Okay. So can you see my PowerPoint screen?
Yeah, looks good.
Okay, wonderful.
Yes,
So
sir.
can you see the mode that I have it in? This is slide presentation mode. Do you see it?
We see the PowerPoint window.
Good. Okay. So in this talk, what I want to do is, I realize that many of you may be more knowledgeable than I am in terms of blockchain and things like that, is give a talk from AI that focuses on, what we deal with as an AI professional. What are the real issues? What do these terms mean? Because you hear so much hype and exaggeration out there in the field. And when we're trying to solve problems in the real world, we need to balance out what things are at a very high level, how they work, what are the challenges? And where does Satori fit within the larger community? What's happening with the AI field as a whole? So I'm going to try to address some of those issues and try to get it. You don't have to be a PhD in computer science or data science or mathematics to understand this talk. You just need to be able to, grasp some of the concepts. Trying to get it to progress here. Let's see. Hang on. Ah, okay, now I got it working going forward. Okay, so Jordan summarized my background. And I'm, originally electrical engineer, then went on to become a computer scientist. And the whole data science field as it exists today is really synergy between computer science, and engineering and applied math. So a lot of the same approaches, the same techniques, they're out there across different fields. They may have different names. And the trick with many of these things is to be interdisciplinary, to learn from many different fields. So when Jordan approached me on this project, and Will made the original introduction, what had me excited about it was a chance to do some further work in an area I've worked in for years, time series analysis. But also, I'm coming as an outsider to the blockchain community, in the crypto community. And I have kind of mixed feelings about what I see happening there. There's always the question about, well, if you're doing a crypto project, is it going to make a world a better place? People are creating currencies and they're using large amounts of energy, but we have a responsibility, social responsibility and otherwise. And what excited me about this project was that it's trying to do things that have utility, because there's a need for people to go out there and to apply machine learning and other data analysis to different data sets. Not everyone has uh, the computational resources to do so. So that's a need. People are paying money to do this anyway, however they do it. And this is a way to distribute some of these computations in a rigorous way across the internet and across computer resources throughout the world. And it's something where when you tie that to blockchain, it's something tangible benefit to our real world. So some of the other members of the team, obviously my background is as an artificial intelligence researcher and a software engineer and software systems architect. Jordan is leading this specific project. And again, for those joining outside this community, in a few more slides, I'm going to get to the discussion of AI that you're going to find pretty fascinating, and maybe in a way that you've never seen some of these issues presented before. And so Krishna has been the main developer working on many of these different tasks. And Sebastian's the community manager, and there's too many other people to mention that have contributed to this project across the United States and across the world. We're so very excited about it. Okay, so I'm a technical guy and, a tech geek here. And, sometimes I have to wear two different hats. One, as a technologist, and the other as a small business owner or working as part of a project that needs to get funded or succeed in the real world. And there's this balance. I sometimes get horrified when I see some of the marketing hype that's out there in our field for artificial intelligence, because I've been in this field for 35 years, and we need to present things responsibly and realistically. So I love this picture that I have on top. If you're not familiar with it, it's St. George slaying the dragon. So of course here I'm envisioning the people that understand the technology slaying the evil marketing beast. But that evil marketing beast, it's hard to defeat. Having said that, the reality is we need a balance between marketing and promotion of technologies and understanding their strengths and limitations, so we don't oversell things and damage the field or have people get hurt. This is critical when we're talking about things like responsible AI. How can we use AI, present the results of AI in a responsible way that makes our world a better place? So I thought I'd start out with some definitions. There's not one definition in the AI field. There's many different overlapping definitions. But for our purpose, artificial intelligence system is some kind of engineered or machine-based system that you have objectives or things you're trying to accomplish, and it can generate outputs such as predictions, recommendations, or decisions, or decision support be included in that will ultimately influence real or virtual environments. A wide range of things, from controlling aircraft to doing scientific models of complex physical phenomena to even helping research scientists that are doing theoretical physics, astrophysics. There's such a range of different applications. Um, and the AI field is a pretty broad field. It's people today, I've even seen professors make this mistake. They oversell sub areas like machine learning, which is important, but know that it's a broad field. you're not locked into one limited set of approaches. So within this larger field, um, you have machine learning, which deals with trying to fit parameters based on data. The other kind of complementary end of the AI field is what's called knowledge-based systems, where you start with assumptions of knowledge that you have about something, and you represent either rules or ontologies or things like that that deal with knowledge. And then within this large machine learning field, there's a sub area called deep learning, which deals with uh, more complex models using artificial neural networks. So within that sub area, there's another sub area that's called large language models. Large language models are again are a small piece of a much larger field. And when we deal with enterprise AI, which is the goal for many applications, we need to realize that many of those systems manage and protect large amounts of data, and the data, you might have issues with intellectual property, with data privacy, with data security, and with reliable functionality. So the Satori project is not magically going to solve the problems of AI, of enterprise AI. What it will is that we can learn from enterprise AI, and we can also provide some pieces that can help enterprise AI. So a big thing here, when you look at the machine learning and artificial intelligence field, you're like an inspector, Inspector Clouseau. Since I like squirrels, I created a squirrel inspector here using a generative AI tool itself. And what is really makes us think is that we're trying to solve problems and trying to deal with a vast amount of information out there and put a magnifying glass or a focus on some data or some transformations that can help us better understand what's going on or what decisions to make or whatever we're trying to accomplish. Artificial intelligence does not need to emulate human intelligence. Some of the early parts of the field, they were trying to either emulate how humans did it through knowledge-based expert systems, or they were trying in an early point of machine learning, deep learning, where they had distributed models that abstracted some aspects of how the brain works, but really didn't model the brain itself. But the important thing here is that it's an engineering discipline. We're trying to solve problems. We're not going to say that tomorrow we're building a super brain that acts like a human brain. We're focusing on how we can solve problems in the real world. So when we do these things, we need to understand the history of the field and some of the challenges. So there was this chess playing system called the Turk. And what they did, this was a few hundred years ago, was they had this box that they would cart around to different cities, and they would have masters compete against the Turk, and the Turk would win occasionally or even many of the times against some of the top chess players in the world. And so what many people did not know was that this was not an AI robot. This was a person hiding in a compartment hidden underneath. And like magic today, they'd have some mirrors that were going on, and they'd show, look, there's nothing underneath. This is just this wonderful automated system. And then they close it, and the person gets comfortable, and they work levers to operate the chess pieces. And the reason that the Turk beat so many masters is that this guy was one of the top people in the world um, as a chess player himself. But it's dealing with issues of transparency, which is a very big deal with AI, which is, are you presenting information that's accurately representing what you're doing. Another issue with AI, more generally, is responsible AI. So in the Eastern European Jewish folk literature, there's the Golem of Prague. Golems were kind of a concept from both Jewish folklore and also from some of the Greek legends. They're basically an automata that does not have a soul, that was created either using the name of God or using magic from some of the core elements. And then the person that created the golem gives the golem commands. Well, the golem doesn't always follow those commands to the intent of its creator. And that's one of the challenges with AI today is you have an intention. Someone says, I want to create a picture. I want to I want to move a robot in this way, and I'm describing how I want it to move. Well, how can we go forward with these kinds of difficult things and deal with the challenges ahead? Another example would be Aladdin. So Aladdin, again, the same thing. You hear, horror movies about genies and things like that, but the idea is the person makes a request to the genie, and the genie basically tries to accomplish that request. Does it accurately reflect the inner wishes of the person making the request? Not always. And here's another classic one, Sorcerer's Apprentice. So we have a sorcerer, and the sorcerer left his apprentice behind, and the apprentice didn't want to clean. Hey, as a single guy, I could tell you cleaning is not on the top of my list. So, he created this magic to set up all these mops and brooms and whatever to do the cleaning, and it went kind of bad for him. So, again, responsible AI. Can Does the AI reflect the request, and is the request a reasonable request to do? These are all some of the challenges with responsible AI. Okay, well, what I did was the previous slide was dealing with the actual image out of the original book, Sorcerer's Apprentice. So I went out and used a generative AI software to generate an image for Sorcerer's Apprentice. And you see here, these images are kind of different. So right now, this one has Mickey Mouse, whereas the other one didn't have Mickey Mouse. And what does this demonstrate? This demonstrates bias in the data. Because in the recent literature that was used to train some of these large language models they use for generative AI, they're using a lot of the things like the Mickey Mouse movies, and they weren't using more of the classical original story. So it biases the result that I'm getting Mickey Mouse and I'm not getting something that looked like the other uh, picture. And this is a big thing for all different kinds of AI problems, in that how do we deal with biases inherent with how we collect the data? Satori provides some ways, but doesn't completely solve the problem because it has to do with how we provide data, how we generate data. So here's another picture. So one of the goals of the Satori project is that you shouldn't need to be a computer science or data science PhD to use it. So one of my friends volunteered, he's not part of the Satori project, to give us a picture of a crazy AI guy. You won't need a crazy AI guy in-house. But then to further illustrate the point of data bias and not always getting the result you expect, I then put in, his name and a description of him into generative AI system. And I get this image that doesn't match the original person. So you notice it's clean shaven. Why? Because that's the bias they have about AI researchers. I have a beard, my friend has a beard. but this generative AI gave me something without a beard. A little bit about the history of AI and time series forecasting. So I'm going to do one sweep through this, just talking about the general history. And then I'm going to talk about my own experiences within this history, what was happening, across the country that I saw, including in the state of Utah. And most of this will be what's called AI, but some of it will be time series analysis. So again, a lot of these different fields, electrical engineering, applied mathematics, computer science, statistics, they're all really tied together. When you look at things like machine learning and AI, the same techniques have different names. So 1927, there was developed some of the original classical time series models. And then in the 40s, they started using computers to model the human brain. And some of these efforts inspired the Turing test, which is what is intelligence and how can we evaluate if a software or computer system or even an analog system or device can exhibit intelligent behavior. And in this case, they were using humans as their baseline to compare it. So then after that, they started up two complementary fields as distinct disciplines: artificial intelligence, which is really more of an engineering discipline, and cognitive science, which is more of um, a discipline that is focused on modeling human cognition. And they overlap, but they're not the same thing. So then the development of the first artificial neural network, which is the foundation for modern deep learning algorithms. And they defined the term machine learning. So again, it's so important in our field just to define terminology. And so even though machine learning existed before that point, to give it a name and to help define what it is and is not was very important. Um, Knowledge-based systems were developed that tried to quantify how do human experts solve difficult problems. And DARPA funded what I would call the first wave of AI systems. And I'm just checking really quickly for my friend that's trying to join the talk. She's going to join on YouTube. So um, anyway, what's happening here is that there was a bunch of money and a bunch of hype. The 60s, the 70s, the early 80s, all this money and a bunch of promises that ultimately were not met. And there was this backlash. And I talk about the balance between marketing something and doing things rigorously, understanding the strengths and weaknesses. And then that led to an AI winter where research continued, but a lot of the funding dried up and a lot of the practical applications didn't continue. And then we saw a resurgence in the 1990s, and then taking us into the 2010 and 2020s, we saw this increased data availability and a lot of foundational pieces that came together to allow these things to be real, to be used in practical ways. Before I go to the next slide, I'm just going to talk a little bit about my own experience during some of these different stages, what I saw happening in the field really quickly. So I started working in the field in the 1980s. And if you took courses at the university, like at Johns Hopkins University, a heavy emphasis was on logic, software systems that do logic. And when I came out to the University of Utah, Peter Conwell and Neil Cotter were starting up courses on connectionism and artificial neural networks. They were out of electrical engineering. And Tom Henderson, who was one of the main leaders at the University of Utah in artificial intelligence, was doing courses on more traditional AI. I say traditional, I really should say classical AI, types of AI that deal with knowledge, that deal with symbols and manipulating symbols. And then, that kind of, in Utah at the time, two of the most high profile projects in AI were some of Tom Henderson's work, particularly that for the dexterous hand, which was a hand robot working with Steve Jacobson and later with Professor Hollerback and others, Sanford Meek of mechanical engineering. And then you also had some very good work done in biomedical informatics. You had the Iliad system and the HELP system that were inspired by University of Utah and Intermountain Healthcare. And I was a grad student. I was studying for my PhD at University of Utah, and they created a new geriatric center at the VA Medical Center. It was a national research center, and I came on first as a software development and later as a researcher. And we were involved in different aspects of the patient record. I had a grad student, Yuri Israelevsky, sorry, he was undergrad at that time, Yuri Israelevsky, who worked for me then as a student intern. He later went on to be a vice president of Google. A lot of these people, we know each other years later, and now Yuri has his own company in Park City, I believe. And so the big challenge was again bringing in the data. If you're dealing with medical data, you need high quality medical data. If you're dealing with military systems, you need high quality data. Data drives everything. And then also, I should mention Bob Kessler at the University of Utah did some Lisp programming systems that was more symbolic AI. Okay, so fast forward, I was a researcher for the VA. I was instructor at the University of Utah, started my small business, and it was very hard to get AI research projects. So many of the projects we did were systems developing software to collect data, not necessarily just AI. We had a mix. For example, we did the electronic patient record for paramedics and EMTs for the state of Utah for 10 years. And the field started evolving further. And again, in the 1990s, I was running regional conferences across the state for cognitive science and AI related things. So now I'm going to kind of get a little bit more into some of the concrete things that are happening today. We're jumping ahead. So AI is being used in a more widespread fashion. There's a need for standards, to protect people, to protect intellectual property, to deal with the challenges for technology that many are overhyping, but has difficulty understanding what's really happening to create safety and use it responsibly. So there's a variety of different standards efforts out there and ways of dealing with liability. Because when you create a technology like this, the challenge has always been what can you standardize? What are the best practices? And some evil attorneys might say, hey, this is something being used. How can we sue based on it? I have many friends that are attorneys, but this is a real thing. Liability and risk will drive usage. If people's personal information gets out there, or if, God forbid, you have someone that is using a chatbot for mental health and is presented as a real person and it influences someone and they kill themselves. This has happened, things like this. Where's the responsibility? How can we prevent bad use of these incredibly powerful and flexible technologies? So NIST has created a AI risk management framework. This is not like a standard where you have to do everything to be able to use AI. It's more of a way to characterize and look at difficult problems and say, how can I understand the risk? How can I understand the challenges and identify in my organization and in the data what I can do to mitigate the things that can go wrong, that can hurt people or hurt my organization while still using the strengths of AI. And so here, A big thing that Satori project gives us, I believe, is to deal with the issue of trustworthy AI. This is the single biggest issue when we're dealing with risk. Is people would ask, well, what can I do to allow someone to trust that I have this black box or this system they may not fully understand, and to be able to use it in a way that they feel comfortable. Because if they don't trust the technology, it could be the greatest thing, they just won't use it. You're dealing with very conservative organizations like healthcare and legal professions or military, where, public safety, where people can die, where people can be permanently damaged if things are not done responsibly. Analogy would be almost like nuclear power. It has tremendous potential, but also tremendous potential for harm if not dealt with properly. So we deal with things uh, is the system going to be safe? Is it going to be reliable? Resilient? Can we explain what's happening inside this complex model so a person that's not a PhD scientist can understand what's going on? Can we protect privacy from the data? And can we deal with the challenges of biases within the original training data or assumptions in the models that can cause our solution to favor certain populations or to not represent reality? And it could lead to populations being marginalized, to people not getting fair education, or to people dying with certain kinds of vehicles that can't take into account certain situations. We need solutions that are valid and reliable. And we need, the ability to have it be accountable and transparent. So there's a diversity of applications out there. This slide is not meant to cover all of them, but just to make you think. When people say AI, some people think large language models. That's such a small part of the field. So the types of data that are serving as inputs and the data generated, that impacts the kind of AI solution, the type of model or architecture, and there are, hierarchies of these things. There are literally thousands of machine learning and similar models that are out there today. The tasks to be accomplished and the building blocks that one would use to then piece some of these things together to take applications of interest within application domains such as healthcare, air traffic control, physical modeling. You might want to generate an image from a prompt, and in one application, another application, you might want to analyze an image for military use or to do healthcare diagnostics. And some of these applications may actually use some of the same components, even though they are widely different in how we're using them. So the Satori project chose to focus on specific sub area of application, which is time series analysis. And even within time series analysis, within forecasting. So time series are a series of data points that can be organized according to temporal order, that is by time. So an example would be Bitcoin or the NASDAQ closing value, or some other set of data that you can have that ordering information on it. Time series forecasting is taking a data set like that and trying to model it and to predict future time series values. So this is a very difficult problem. So the list I have here, I'm not going to go through every one of these right now, but the idea is that time series forecasting has to do with a variety of things, from the assumptions you make and how to use them, all the way up to the available resources that you have. And this diagram is an example of a simulated time series. Christian and I yesterday night, we just threw this together. So we have imaginary time series that over time, it follows somewhat of a linear pattern, but its noise increases over time. So we have these wild fluctuations. And you could take the data set and you could build a model. In this case, we just used a linear regression model to illustrate some of the challenges of time series modeling. So we could also have cycles in the model that, daily cycles or weekly cycles, monthly cycles, or yearly cycles, depending on whatever we're trying to model. And so with some of the Satori capabilities, what is the Satori framework trying to give us here relative to all the things I've presented? Well, we want tools for developing, training, testing, and validating predictive models. That I should have said not just predictive models, but right now, time series forecasting predictive models. But people have these computer resources. There needs to be an incentive for them to share their resources. These resources cost money or people time. And also, the big thing is to tie it into some kind of decentralization and transparency. The solution right now is still evolving. There are challenges ahead, but that's the goal. So then how does this tie into the NIST framework? If we were to map some of those requirements from the NIST framework onto what we're doing with Satori, well, resiliency. We wanted a decentralized approach and network implementation to enable these things to be resilient. We've not yet implemented explainability and interpretability, but this is something that I'm familiar with the techniques and tools for this, something we can add. And with the issue of harmful bias management, so the Satori project will not by itself completely solve this problem because it depends on the data streams. The data that's even collected, but we can provide some tooling to help with this if certain assumptions are made. Try to democratize the process, who can provide data sets, and as more and more data sources become available, we can deal with that, and we can even weigh different data in different ways to accommodate the fact that the data we have may be biased towards certain types of populations, but we can adjust that. Valid and reliable. So this is a big value of what we're doing here is we can generate predictions and interval estimates. Right now we're focusing more on the predictions, but we've also done the interval estimates, which take longer, and rigorous ways to test it. And then we can have people across the world that are running these things, and we can rank them. And so this is one way to do independent verification and validation, is to have them be tested on data they haven't seen. And as a research scientist, a lot of times what you have in the scientific literature is people will develop a model. It's a machine learning model or anything else. And the question is, they've developed this thing. They say, our model works great. Here are our results. And you can't always duplicate what they've done. And the same for the machine learning community. So you have to be really careful. Do we have an independent arbiter that can test these things, against data they haven't seen to see how they work? Accountability and transparency. Publish the information in the competitions, their results, and their models. Potential for future sharing of trained models. Now, I'm not going to go in this talk into a detailed discussion of all the theory and all the challenges of each kind of model, but just know that there's this huge search space of possibilities that are out there. We can have different possible data streams. We can have different features within each data stream that are combined to a set of features. We can choose different types of models and even software implementations of those models, hyperparameters, which are tied to the models that determine how they train, learning algorithms, and ultimately the parameters themselves that we're trying to learn. So there are all these different levels, and combine that with the fact that some of these models have different computational requirements. So if we're running it on different platforms, we have to take into account, hey, we want to give this distributed node something it's capable of running. That is, if one model takes 10 hours and the other model takes 5 minutes, and they don't have the resources to run the more computationally intensive model, we have to customize it for them. And there are trade-offs with performance, but it just depends on the situation. And so, again, what can we do to deal with some of these issues with all these different parameters? And there's huge search space that's out there. So we can try to incorporate subject matter knowledge into some of the modeling process. There are professors like Professor Michael Kirby at the University of Utah. That's one of the world's top people in physics informed machine learning. That's not a focus for us right now, but that's one example. Incorporate knowledge of the physical system into the modeling. Something we do in the Satori project that not everyone automates is that if I'm, a PhD level research scientist and I'm trying to model something, a hard time series, then I can take knowledge of the time series. Maybe I know there's a trend or a cycle in there, and that can allow me to create a better model. You can do this by hard coding it, as many examples out there in the internet do, but you can also try to figure out how to automate the ML process. The term that people use is auto ML. So you can take many of the different things you're searching and try to automate them. But the mistake that many people do with auto ML is they're not using the results of statistical tests. So we want the best of both worlds. We want to be able to automate some things and also automate some statistical tests and try to combine the results of each. And what is that? And I'm going to give you kind of a reality check on some of the challenges we deal with. We can do everything right, but these are still difficult problems. I was up 3 a.m. in the morning working with Krishna yesterday night, and I was struggling whether to include this slide in the next one. But I decided to do it because there are challenges, even if you have the best possible model given the data set that you have. There's still processes in the data that, unless you have a tight enough sampling frequency, or you can't always predict things out a certain number of future time steps of what will happen, because there are things that you simply can't predict from what's in the data. So what we're trying to do with this project is do the best we can with the data available. But ideally, the green line is representing a prediction that we built using the recent version of the Satori software that has some of the more advanced models that Christian and I have been working on over the last 2 months. And the goal is to get these as close as possible, but it's not magic. You can't always match these things exactly, because there are limitations in the underlying data and what you can predict from it. So that was an example of Bitcoin. I want to use a real world example. Bitcoin is something that people track. Another one was the NASDAQ closing values. So again, the results are not terrible. We're looking at maybe a difference of 0.2 out of a range of maybe 20. So I don't know, maybe like percent disparity. And so what can we deal with this? How do we deal with challenges like this in the future? What can we do to make these things even better? Well, the first thing we need to do is understand our limitations, be realistic. So this picture over here is, of course, an oracle riding on a unicorn, because as people map time series forecasting and prediction to an oracle and a unicorn. But of course, do these things exist in the real world? What we need to do as engineers is identify where we can improve things and what can we do to make them better. So one is realistic expectations and the responsible use of AI. learn the theory that we're building in. We're learning the theory so that the people using Satori don't need PhDs in these areas. But we need to understand what are the best practices, what are the best models, what are the best software tools that will allow us to automate these things. Also, a variety of data, because that result I showed you on the last two slides, that was only using the data to predict its own values for the future. And it was doing it several time steps in advance. So if we had more frequent data sampling, and if we frequently updated our predictions more frequently than, let's say, doing it several days in advance, then we can get that behavior. And it's a trade-off between how quickly do we update the model predictions versus other factors. So we can be better, we understand the strengths and weaknesses, and also finding related data that can serve as inputs. For example, Bitcoin, that there's the issue with the Federal Reserve. That can be a predictor for some of the changes in the Bitcoin, models and predictions. So then once we have that, for transparency, we need a dashboard. So this dashboard is a mock-up that Jordan created. But I'm going to talk to they have an existing dashboard that those of you in the Satori community are using now. Is we have competitions for different data streams. And eventually what we're going to have is, instead of just looking at one time step in advance, the models that Krishna and I have implemented can do multiple time steps in advance. And we're going to be comparing these things and ranking them. And that's what's happening now to some extent, and then learning over time for certain data sets which classes of models work the best. Because what you'll find in many cases is that deep learning is really cool and sexy, but the literature says that sometimes a collection of simple, stupid models combined together can outperform deep learning. So we need to have that flexibility of even running many of these simple, stupid models and even aggregating their results. And, this gives us kind of a way to have that transparency. So this is, again, jumping back to the NIST slide. Again, just hammering things over the head. We're dealing with resiliency, explainability. We're dealing with biases, valid and reliable, accountability, and transparency. Well, where can we take this in the future? We have a lot of room to grow with what we're doing. We're laying a solid foundation. Comprehensive AutoML. Automate as much of this as we can. And this is driven by using the right tools to tie in many different data streams. There are different possible data sets, configurations, deployment options. Automate this, and then use the strength of distributed computing to run these, on different nodes across the world. Peer-to-peer capabilities so that we won't always need this central arbiter, but that we could have peer-to-peer competitions that are equivalent. But then let's say I'm an organization and I'm very gun shy about the internet. I don't know who I'm dealing with out there. It's the Wild West. So maybe I would feel better if you could train a model and you could send me your model and I could run it locally against the data set, validate it myself. And so these two over here are related. So one way would be, hey, I want to incentivize you to share your trained model with me because it's a good trained model. It's the best of breed out there. And maybe I want to combine it with other models. Maybe I want to use it myself, and I want to use it inside my organization, maybe to analyze proprietary medical data where I simply can't pump that data out there on the internet. And another thing is, when you say your model's good, maybe we have a record of exactly the details, your parameters and all these other things on blockchain in the future, so that, hey, they ran this model with these parameters on this data set. I'm looking at it, I can try to duplicate that, see that, there's a record in blockchain of that. Explainability, interpretation. Again, this is going to be critical for some applications. You're telling me to do something. Why should I trust what you're telling me? Okay, you give an explanation that I can understand. Depending on who the person is, that explanation may be different. And for situations where, there's incredible strength in the blockchain aspect, but what we're doing and going to do with the machine learning and time series analysis algorithms by themselves have strength. So that could be used by organizations that simply can't put their data out on the internet for others to run, but they'll have a tool set that they could potentially use in-house when you're dealing with very sensitive data that requires privacy or protection. So again, restating what's the value of a Satori network to the AI community? It's a way to enable trustworthy AI. We can learn from a variety of ML, DL on diverse data sets, and in many cases, Occam's razor. We can sometimes find that simple models outperform these really complex ones, and we can chain together or combine simple models in some cases. Again, this combination of AI and blockchain technologies, it allows us to distribute the computing resources to perform some of these and seamlessly integrate these open source libraries and AutoML, and it avoids the need to have your own in-house PhD level research scientists. And as I previously discussed, pieces of this project could be used internally by enterprises that can't share their data. So this is my contact information. I'm going to hand it over to Jordan to basically see if there are any questions, and I'm going to try to stop screen sharing, okay?
Thank you, Jerome. Thank you. Let me come back online here. Thank you very much. That was awesome. We have a diverse community here, and I don't know if many of you have heard Jerome talk before, but you can tell he comes from a business academic background. We have people from all kinds of backgrounds, and so what I'm excited about is that we can have these discussions. It's important to, be able to see things from everybody's perspective, I think. And so thank you very much. I'll open up the floor. Again, if you want to ask any questions, if you have anything at all, I think we probably don't have to unmute you, but let me know if that's the case. And but just state your name and then whatever interested you, and then let's just open it up to the floor for any kind of discussion.
Hello? Can you hear me?
Yes.
All right, Dr. Soller, Jordan, how are you? I just want to thank you very much. This was absolutely magnificent, and it was I'm sure we all found this extremely fascinating, and taking a look behind the curtain at kind of what's going on in the background and your whole mentality and ethos, both between both of you guys and everybody. This was just really spectacular, and I like how you touch on things I've never even heard of or even can slightly comprehend to some extent. But I do, as being a person of science in the background, the diversity of acknowledgments into every possible, I guess, situation and type of I don't know, thought process, all incorporated cumulatively into something, that does require, diverse variety of inputs is really, it's super spectacular. And I'm just absolutely, I'm just extremely appreciative, and it's super awesome. And just can't wait to see where it goes. And thank you very much, everyone, for making this a reality. It's truly awesome. Thank you.
Thank you for attending.
Yeah, it's Dead Head here, and I'm enthusiast OG here. Question: how big of a network do you see Satori needing to be viable for business use? In terms of computing power, neurons, however teraflops, however you want to compute that.
It's it's a really hard one to say general business use just because there's so many different problems out there. And that's what I'm trying to get away from, is that it's really so one aspect business use is the data governance. So the distributed Satori, like I said earlier, won't necessarily be used for some healthcare applications because they're suing people over medical privacy left and right when AI is being used. It's really, they can't put the data out, but you need to find, so again, there's two things. One is using it within an enterprise without the blockchain components. It just depends on whatever problem you're trying to solve. I know that, you remember I showed that picture with the alchemist, and they were trying to determine the parameters, and there's no one single answer because each problem is different. So I can't just off the top of my head. It's trial and error. For the large language models, if you're building your own large language model in the broader field, that's very intensive. It depends on the data set. Um, these things evolve. I can't give you a single answer to this because it's so dependent on the data set and the level of accuracy you want to consider acceptable. I'm going to throw this question back to Jordan to hear his thoughts, but I can't pin down it for every situation.
That's a good question. I'm not going to pretend to know either, but I do know we make about 10 million predictions a day right now on about 4,000 to 5,000 data streams. And that's with a network of about 20,000 nodes. And I as far as my personal vision, the big vision that I started with, we have to always see how things will evolve. But the way I anticipate things eventually going is that we're able to build a model that looks at all the largest, most effective. They affect the most number of things. The most effective data streams in the world, and model their interaction with each other. And I think once we get that layer finished, and I don't know what that will take, I assume, it seems like you could do it with what we have today. If you organize all the neurons to look at those particular data streams, but once you have it, you can then start providing some business value because you are predicting things that will affect lots of different businesses. Now, I don't know what that looks like in particular. Like Jerome was saying, it comes down to use case when it gets to that. But the larger and larger it gets, once you have that kind of baseline, and I don't see why it would take any more computers than we have today. But once you get kind of a baseline, and you start to grow beyond that, it seems like you just get more and more detailed and you start seeing more and more resolution. So it's kind of a question of degree in my mind rather than like a definitive kind.
And I'm going to answer a little bit more. So what I was saying before is that what accuracy are you willing to accept? What risk are you willing to accept? And I was talking about, that some data they won't go out on the internet, but there's a large amount of public data that's already on there where it's not an issue. So I could see, for example, marketing applications. If you want to understand marketing trends, and if you're not providing proprietary data, you simply want to look at analyzing public data, you're less concerned with those proprietary issues than you would be for electronic patient records with all those privacy issues. So I think that there's potential to be targeting those kinds of problems in an intelligent way. And one other last point on this, what's enabled all this wasn't really just the theory, because the theory was around, as I showed you, since the early 1900s, much of this. It was the computing resources. So what do we have looking forward to in the future? Well, quantum computing has the potential, if that goes mainstream, to blow up computational power by an order of magnitude. It's not there yet, but but it leads to possibilities I can't even foresee myself.
All right. Well, if we don't have any other questions, I want to thank everybody for coming. If there's anything else, just let us know. Speak up. But
Yeah,
what's that?
I'll ask another question, and it's more to the liability aside. I'm HIPAA compliant, so I know what you're talking about when you mention healthcare data. If this is run basically as a DAO, or eventually, where would liability lie? We're thinking legally now. I understand ethically and all of that. Obviously, as a coder, and you want to have the most accurate data for a number of reasons. But we don't, how would Satori fall into that realm compared to, say, like a Chat GPT or, a Pegasus that's, privately owned?
Yeah. So a little background, I serve on some committees at the University of Utah that are discussing this, and there's some legal people not specific to Satori, but I can't give you a full answer because this is an evolving field. So what I can say is it will be influenced. The answer to that question will influence the success of this project, and we're trying to be ahead of the curve. Jordan and I plan to meet with the state of Utah. I mentioned this to you, Jordan, to see if we can have this be one of the use cases for regulation. So what happened recently, as kind of I'm not a lawyer, but there were some situations where companies got sued for the use of AI on medical data, and they survived the lawsuits because they could point to best practices that they used to mitigate that. That, hey, they followed best practices and they also had insurance. Now, what I've been told is some of the insurance companies will not pay unless the organizations are using best practices. So what we can do is stay ahead of the curve, is work with regulators, document what we're doing, and also potentially work with people in the insurance industry. But I can't say how every detail will work itself out because it's evolving. I'm not sure. Did that answer your question?
Actually, yeah, you did, because it put me in a little bit different direction. So the onus may be on the, let's say, business that's using Satori, but Satori wants to provide that business with the best possible data and use the best practices within, our organization here, so that as long as we're not a liability to the company using the service.
Yeah, I'm very nervous if Satori takes the responsibility for a model and they use it in a way we didn't anticipate. God forbid someone, runs this thing and it does a prediction of the stock market where there's inherent noise and volatility, and then they lose their house over that. We want to avoid a situation where they then sue the Satori project. Hey, you had a model running on this system and I followed it and made a decision based on that. So, it's a challenge, but we're trying to be ahead of the curve, that we realize that these are potential problems, not ignoring them, and just say, okay, how can we mitigate it? How can we work with the regulators? How can we have the right disclaimers? And at the same time, be responsible for what we're doing. Try to do things with all the best practices. But that can't prevent every possible thing from going wrong, because we could do everything right and something can still have a problem.
Quick question, Ricky. By the way, good chick here.
Hi, yeah.
At all about the security or Satori being targeted at all in any way?
What was that about security?
Are you worried about the security of Satori or becoming targeted in any way?
Not sure I heard the second part of the question clearly.
I think, are we worried about security or Satori being targeted in any way?
I mean, I'm going to be honest, Jordan and I have had these discussions. When you use a system on the internet um, that starts becoming prominent and has usage, it's a threat, and there are steps that we can take to harden what we have. And Jordan and I have started these discussions. It's like many of these problems, it's a difficult problem. It's a challenge that we need to address for this project to be successful. And we've started along that path. I mean, if you're familiar with the NIST, NIST, NIST has 172 security controls. The Department of Defense security is based on that. But I'm not an expert on the crypto tools. I'm more knowledgeable on some other aspects about the security, and just as we would do a risk analysis, and that like the risk frameworks for using AI itself, we're going to need to do a risk analysis of the Satori system and try to mitigate the points of risk. So it's going to be an ongoing effort. It has to be, to do something that people rely upon.
Yeah, exactly. And that question has multiple domains of, like, there's lots of different attack vectors because there's lots of different domains in which Satori exists. The legal domain can be attacked. The network itself can be attacked. And so one thing we're doing on the network side is the making it more peer-to-peer. We have those pub sub servers, and they've sort of managed our peer-to-peer communication through a centralized server in order to send out the data, but they could be targeted. And so right now we're in the process of building the peer-to-peer system so the network can communicate directly. And we also have data redundancy so that data is saved on multiple nodes. The data that a neuron consumes is saved on that neuron. There's a copy of it. And the data that it produces is also saved. So there's a lot of redundancy in the ability for us to kind of potentially recover if there's any kind of attack. But so yeah, we're familiar and aware, and it is something we always have to stay up on, for sure. All right. Well, if there's no more questions, I just wanted to say thank you, everybody, for participating and listening. And this is the first talk. I thought it was really good. Jerome talked about a lot of things that we've discussed in depth. I love how he went over kind of the vast search space that's going on, and that how some of the things he mentioned, like they translate directly to like when he mentioned that we can build models potentially that compete with very large deep learning neural nets just by combining some simple models. These models can be trained on CPUs, and most of the network is made up of CPU power right now, and probably will be for a while. So even though we're building like GPU algorithms into the engine, and we're getting able to leverage GPUs because we can do so many things with CPUs still. I think that's a really powerful thing that seems to, like, a lot of deep learning or just AI interest is solely focused on GPUs and doesn't realize the power, especially in this niche time series forecasting domain, the power that we can achieve with simple models on CPUs if you do it in a distributed or multi-model fashion. So anyway, there's lots of things in there that I think Jerome touched on that was really impressive. But thank you again for coming. If there's anything else, otherwise, we'll. What's that, Will?
Yeah, we have a few questions on the chat. I don't know, you're monitoring the chat on the
Oh,
Discord.
sorry, I didn't see. Yes.
Yeah, so they asked me to mention you about that. There's a few questions from the community, so if you can
Do you want to read some of those if you found them already?
Yeah, of course. Yeah, so the first question is from Vic. Is the community are waiting for that, and when will it be the bridge, and is this ready?
Yes, I see the question. Let's see. About the bridge, when is it ready? Okay, so the big problem with the bridge, because we started looking at the bridge a long time ago, like a bridge possibility. I felt it was early, but we started looking into it anyway to see what kind of possibilities there are. And the big problem with the bridge is that it's very difficult to make a bridge in any domain that is non-custodial. And we want to do it in a non-custodial way so that we don't hold anyone's tokens. So most bridges don't do that. In fact, almost all bridges are custodial bridges. And that was something I didn't want to believe. But after doing all the research and looking at what the possibilities were, that's the truth. So most bridges are very custodial, which is okay. I mean, I have no qualms with that, but we want to make sure there's no legal issues. So we needed to make it non-custodial. So we have finally found a design that allows it to be non-custodial. And we've been, I don't know about building, we've been designing it out. And so now that we have the design and it's very detailed and we know how to build it, we can start building it or maybe contract that out. We don't know, but we can start building it soon. So I don't have a timeline, but I would probably say Q1 of 2025 is the goal. So that, I guess that probably opens the question of, are we moving away from ever? And I wanted to just say, no, we're not moving away from ever. So the idea behind a bridge is to say, Satori is a, wait, hold on. Sorry about that. Satori is a project that's should be multi-chain project. It should be an omni-coin. It should be a concept that exists in multiple domains. And the reason for that is, well, there's several, but one of the reasons for that is it creates resiliency. So we don't have to be everywhere, but we should be in, we should have options. We should always have our options. And so the plan is to have a bridge and to be able to bridge Satori token somewhere to an ETH-based system, if it's not Ethereum itself. We haven't decided. But, and then that way we have an expression of the coin on a different platform as well. It would have all the same rights and abilities. So it would be the same concept, the same token. Anyway, that's the plan with the bridge. Thanks for asking that question. What other questions do we have?
About the CX question and another one about new pool feature that you put that in the progress today.
Yeah, centralized exchange. I have no plans to push a centralized exchange personally. This is a community project and the community can do whatever it wants. We are on 2 exchanges already, and I was not involved, and the team was not involved, I don't think, at all, in getting on either of those exchanges. I was surprised. I was blindsided by the first one for sure. So I think that's cool that projects or exchanges picked us up. But we really don't have anything to do with exchanges. And the community, maybe we can, if there's an initiative to get on a centralized exchange, I personally feel like just if you're going to have a bridge over to the ETH ecosystem somehow, you might as well just get on a decentralized exchange and call it good, because then those that hold Satori can benefit by joining a liquidity pool and earn the fees of the liquidity pool. So to me, it kind of seems like, why don't you just do it that way? Decentralize as much as possible. But, I don't know everything about the ecosystem or anything. So it's just my personal opinion. So there's no push for me to get on a centralized exchange. As far as when marketing, so we want to do some marketing. Well, I think once we build the bridge, more marketing will naturally come. Come again? I think once we yes. Okay. So I think the marketing will come naturally when we build the bridge, because it's a larger group of people. And so, but as far as continuing to just make, I went on a lot of podcasts months ago, and I kind of stopped that because we were in development mode, and we've got a lot taken care of there. It's not as I guess frantic might be the right word. I'm not sure, but we don't have to do that as heavily. And so I have some free time to go talk on podcasts. We would love for the community to introduce me or any member of the team to podcasts. And that way, we get on podcasts that community members are familiar with. Everybody knows about it. People listen to these. And I can just talk about Satori. That's kind of the only marketing plans that I personally have. So, as a team, we're focused mainly on the product right now. Yes, there is an important. We need to do marketing. We need to have that aspect. I'm hoping that comes more from the community, and so I'm planning on doing kind of a baseline amount where I'm able to go talk on podcasts and kind of get the word out. And anyway, that's the plan for marketing at this time. And so we're going to make kind of a copy paste template that anybody can send to podcasts that they want to introduce me to, that will allow the podcast to immediately connect with me. They'll have my calendar or any member of the team's calendar. And so that'll make it easy. They'll have my bio, they'll have background, a copy paste that we can send out and get on various podcasts. So anyway, that's kind of the plan at this point. Were there any other questions we have to go through? Let's see. Yeah, why don't we hire influencers to talk? They'll come on their own, because we have an incentive that is not turned on, and that is that if you introduce the Satori, running a Satori neuron to others, then we have a invite incentive, and so we're not going to turn that on automatically. We might put it to vote. But we'll figure it out. But that will provide an incentive for any influencer out there to kind of talk about Satori, explain what it is, because they'll have something that they can share. Anyway, that's kind of the plan there. We don't want to hire marketing because if we need to, we will. Absolutely. But right now we're just focused on making the best product we can. And when people can see that it makes predictions, it'll speak for itself. I don't know. Anyway, that's kind of how I feel at this point. Jerome, you talked a little bit about the balance between marketing and the product, I guess.
Yes.
Do you have any other thoughts on that?
Well, there's not a simple answer to it, but I think that if it's one of the reasons at 3 a.m. I was working with Krishna on some of those slides for the Bitcoin and the other one, and I was struggling because what you see sometimes in the AI field is they only show the results that they're hitting the ideal. And it's really a matter of saying, hey, this is doing a reasonable job, but hey, we can make it better. And it's this struggle. I think that we have a lot of work to get done technically, and there's no simple answer to it, but I think the big thing is just to go in with the attitude that we're approaching this from a position of integrity. This is a difficult problem. We're not going to have flying unicorns like I did the unicorn of flying an oracle on top. We have to be realistic about what we can do. And I think there are mechanisms out there that aren't necessarily just social media ones. Like you and I were talking that we may get some exposure with Amazon and Google through some of the communities that I'm dealing with right now. That's essentially a form of marketing out there. In terms of social media influencing, I think we're all learning together on these things because I don't know as much about social media marketing as many on this meeting, but I'd say build the best system we can, clearly explain its value, what it is, what it's not, and try to create creative partnerships that may help drive some of the marketing. That's some of my thinking, but that's very general right now, very abstract.
Yeah, I feel the same way. And I should also mention, I put some of the features we're building right now kind of in the marketing budget or bucket as well. Like consider our website. Not great, not a great website. I mean, it's fine, but it's not. It doesn't showcase what the network is doing. It just has some stats, and that's a landing page and whatever. But what if you could go there and you could actually talk to the LLM and ask it about the predictions that are being made? We're building that. What if you could go there and you could see a graph of all the predictions on any data stream that you wanted? We're building that. And so, I've never been a persuasive person. I've never been a hype person. And so my attitude is build the things that allow people to see what's going on, and it takes time. And then people that are really persuasive and can get the word out there and show everybody what's up, they can bring the attention in. But first you have to build what they want to show. And so anyway, that's kind of our focus right now.
Yeah, and again, restating that in my presentation, I was focusing on transparency and explainability. Those are just critical things. They have to be able to trust this. And if they trust it, then it'll drive other opportunities.
Hello? Can you hear me?
Yeah.
All right, right on, guys. I just want to second what you just said, being as much as I want to market, but until there's something more substantial to market, it's not, because you can have 1 million users on the network right now, but they're still going to just redundantly be predicting the same 4,000 or 5,000 streams until I think when it's mature enough, or at least maybe in another couple months or whatever. I mean, not that it wouldn't hurt, to throw up some, Facebook ads here and there to get a few more users, whatever. But even with my own company, until I had something that just kind of spoke for itself, and then it was just kind of word of mouth, and it just kind of took off on its own. That, not that I'm not anxious or ambitious to, put a couple feet forward, in regards to it. And I'm still willing to, throw some money, just even personal, whatever, just into some sort of, just getting the word out, whatever. But I know we're all very anxious, to see where this goes, because it's really a phenomenal, probably world-changing, for generations, if the world's around that long, project that you have going, and we all wish it the best. And I know, and I'm really chomping at the bit. I already have, graphics. I got all types of shit going on. But I'm trying to put the reins on them. And I think, yeah, in the next, in the forward-coming months and, whatever, yeah. And I hear everybody's, points it's awesome that everybody's really, on the same page about, cohesively, working together as a team and everything, which is super awesome. And yeah. But anyway, yeah, I think when things are a little more in place, that I think, yeah, you guys have the right idea about just a little more organically rather than trying to force it, you know, and just putting more stress on yourselves and the network and people's wants and complaints and etc. But anyway, I'm right behind you 100%. So just, I'm around. Anyway, thank you.
Yeah,
Hey,
yeah.
just
Thank
jumping in
you.
here.
Oh,
Sorry.
go ahead.
How close are we exactly to demonstrating actual factual, let's say results?
You mean like being able to measure the accuracy of all the predictions or something like that?
Exactly. Like, are we able to say, hey, here's our prediction software. This is how close we are to actually predicting real use case scenarios, and we're bringing it to your attention.
So we, as our first step on being able to kind of see some of these metrics or see what the network is doing on kind of a massive scale, we added it into the neuron first. We said, okay, we're going to grab the data of any data stream. So you can go into the streams tab and you can see any data stream. You can search any data stream, and you can see like that. You can see like the history, and you can see not all the predictions. You can see a summary of all the predictions through time and of the entire network on that particular data stream. Maybe that data stream had 40 predictors or 100 or 3. And so throughout time, we take those predictions, we average them down, we make a summary of those through time, and we can show that. So we can show how close it was. And we don't do a lot of analysis right now on like mathematical analysis on figuring out what the accuracy is over time. We just show it on the graph so that we can see, okay, this is how close it was at this time in history. And here's how close it seems to be now. And this is what it's predicting in the future. And so we have that tab and that visualization. We're making a better version of that. That was kind of our test version. A better version of that for the web. And we're going to aggregate also now. In doing that, we learned we needed to aggregate various data streams, the input data streams. So we have like, I don't know, 5 or 6 data streams that describe the price of Bitcoin. But they're on different timescales, different cadence. They're describing it from different sources. But really, it's one conceptual topic, BTC, USD, or whatever. So we're aggregating those down as well, and all of their various predictions to be able to show the history of what the Satori network has believed about BTC and what it does believe right now about BTC's future. And so now, as far as a timeline of when we can convert that into like even more interesting stuff, like predicting all of the most broad data streams of the Earth in relation to each other and being able to, like, that seems like it'll be this year sometime we'll start predicting those data streams and we'll have data on that. But we're focused right now on saying, okay, we now have this network. It's producing all of these predictions. We have just been producing them and sharing them with each other and then sharing them with the Satori servers so that we can put them on the website, that kind of thing. And that's all we have right now. And so we need to be able to show that.
Yeah,
Exactly. And to add on to my second question, that's great that what you have right there. And so in our data streams, I haven't really overlooked it for data stream results and predictions. Is there a way for it to show, like, let's say, our top predictions that are closest to actual real-time results? and like
Great idea.
let's say you know what I mean. So we have it like like a leaderboard, let's say, and we'll say this is our data stream that we have, and this is what Satori predicts, and this is the what it actually is, and this is how close we are, and this is how progressively better we've become, and this is you can see the rate of growth and the learning capabilities and so on and so forth, and that will actually demonstrate that it's working to people who just don't have a grasp of it at the moment.
Yes, that's the kind of stuff we want to be able to show on the new website that we've been building out. And that takes a lot of analysis. And so we'll be building that kind of analysis out.
That's awesome.
So
Thank you so much.
let me answer the questions from a different perspective. So there's a difference between what we've built into like the machine learning infrastructure and what's represented on the graphs, because not everything has yet carried over. So, when I joined the project, it was primarily some version of XGB, I believe, one single model. We went from having one single model using the data to then being able to have a variety of data pre-processing options available. And now, even though we haven't always implemented all these because they take longer, I believe we got approximately 40 to 50 different distinct models and architectures all working. So going from XGB to about 10 different deep learning architectures. XGB is part of a class of tree and forest models. We have, I think, 15 tree and forest models, linear regression, models that feed back to themselves, as well as models that are considered direct. So altogether, 40 to 50 different models and architectures. And, an issue with transparency is that it's an easier problem to predict one-time step in the future. But the mathematics we have, the software implementation we have right now, though it's not representing the graph, we can do n. We could do a whole day, a week, a month. The further you go out, the less accurate it may be if you're not updating to new data for a variety of reasons. But that's another area we can do intervals and evaluate how well those intervals capture certain things. So the trade-off with all these things is just computational resources and storage also. Because when you get potentially thousands of moving parts, thousands of different parameters, then to display that might overwhelm the user, but we may want a repository centrally to capture that. What I can envision in the future, this is my bias that I've mentioned to Jordan, is to have it where we could say, this is the performance one step in the future, but here's the performance a day in the future, a week in the future. And here's the models that generated it. So you could see and look, hey, John Smith and Peter Johnson are two different people, but they might be running different models. And maybe it's not the fact that John has a particular setting, it's the fact that particular models work well with certain assumptions for certain data streams. And hey, this model works well if it's one step in advance, but this other model works well if it's a week in advance, just because of the nature of the model and the strength of it. I hope that helps providing that perspective.
No, that's a great point. Thank you so much.
Yep. And just going back to marketing real quick, I understand the value of marketing and how important it is to market, because you have to communicate to the outside world. I think we're in a phase right now where we're marketing through these kind of meetings, through getting the word out there, through a lot of the X meetings that Darko's been doing. And so I'm not anti-marketing or poo-pooing it. It's just not my wheelhouse. And so And I don't believe the network is at a phase right now where it needs to be the focus. I like to focus on we do want to grow the network, and I mean that as far as computational power as well. We need to grow the network to be the largest network we can get, so that we can make the best predictions on the most number of things. And once we have the infrastructure in place to be able to do that, to just infinitely scale, then I think marketing becomes way more important. But distribution is king. I understand that. So we always need to have some kind of baseline marketing, or at least communication to the outside world. And so, anyway, thanks for that. You're definitely very right.
I'll add one last thing. So we want to do it in a measured way and in a responsible way. Those are the points I want to make.
Can I say something about the marketing and the discussions I've had with Marco and others?
Oh,
I think
please.
right now, and please, correct me if I'm obviously speaking for myself here. I think our target right now is believers, people like myself and others that believe in the project. And the coin being listed and having such a good price is both a curse and a blessing in that matter. Before my time frame, what I see just in my experience is I'm a year and a half minimum from being able to walk into, say, let's say the shipping industry, worldwide shipping industry, and say, hey, here are these 5 or 6 data points from these major software companies that give you, what ships where, what ships available, who's late, what ports congestion, and all this stuff in. And then Satori adds in the weather data, the wave heights, the price of fuel in different areas, the prediction, a week from now, the currents and everything else, and allows that shipper or that broker to make, decide which ship to take or what route to take or whatever. In other words, a finished product that I can market to an industry to use. Now, I think 18 months is extremely generous on that time frame in my experience from software development. I'm not a coder, but I've had a lot of experience in that area. But that's what, and then our market shifts to not people that want a cryptocurrency. This isn't a cryptocurrency. People, businesses, and individuals that can use those models to further their business and not be beholden to the corporations and the governments on what they want to predict and how they want to predict it. Would that be
So
fair?
that's why I kept pushing the issue of trustworthy AI, because to get it used by companies, organizations where they're taking on a risk for using it, because it'll affect their corporate decisions, they have to be able to justify those decisions and say, okay, it explains this way, they're following this best practices, they're dealing with this box of the picture I showed earlier. They're doing these portions of that correctly so that someone can go to his manager and have them act as a champion. Without you being able to deal with those foundational issues, explainable AI, reproducible, the transparency and all these other things. And in some cases, there may be an opportunity where they may want to run it in-house, but still use Satori to generate the model and then have a transaction where they get a copy of the model and run it in-house. You have to deal with all those things I discussed earlier rigorously, because I'm dealing, what I see in areas like medical and legal, it's not that much less for any large organization, shipping company or anything else. They're just not going to pull some random result off the internet. You have to have this ability at multiple stages, multiple levels to meet their requirements and to justify that it's being done rigorously.
Can I chime in on that for a second?
Please do.
Hey, yeah, so I'm in very strong agreement with the doctor, and I've been thinking a lot here for the last 10 minutes about I think we've talked about our different groups of marketing targets, but we didn't really talk about the quality of marketing targets. And I think it needs to be stated out loud that for every one user that signs up to the Discord and runs a node and creates a wallet and uses the product, every one of those users is worth about 30 to 50 speculative coin users, or what the doctor refers to as the marketing people. So there's, the marketing enterprise users, which are, in a special class of speculative users. And there are speculative coin users, so the crypto people coming into the space. But you can see with pretty much every successful AI project and every successful blockchain project that the core users that come into the space, develop for the space. Well, I keep on hearkening Hugging Face as a good example of an organically grown software project. Is so these are the core users, and those users are marketed to in a very B2B like fashion, like the doctor just pointed out, which is the people on this call have to manually expose the Satori project to others and organically, hey, say, come hang out with me on our Discord user. Our project is cool and you should contribute to our project.
Excellent points. Yeah. So glad you joined our team, Darko, because you have a lot more marketing expertise and understanding than I do. So I'm glad you're here.
I agree with it, and something you may be excited to find out because you used the Hugging Face example. Some of the new models we integrated were from the Hugging Face community. So they're an outgrowth. Some of those time series forecasting models that through another package basically integrated some of the newer Hugging Face models in this space.
I saw a message about the pool feature. I'm not going to describe it in detail right now because it's still in development. We need the pool operators to kind of beta test it to make sure everything works really well. But the basic idea is very simple. We have already solved one side of the pool, the staking side. So people who don't have enough to run a Satori can stake to a pool or whatever. We didn't solve the other side, which is, what if I have a computer and I want to run it for the Satori network, but I don't have any staking power? It's just basically solving that other side is the new pool feature idea. Is a neuron can say, hey, I'd love to join a pool as a worker. I'd love to work. So give me some staking power. I'll do the work, and then I'll rely on you, just like stakers do. I'll rely on you to reward me for that work. So that's the basic idea of the new pool feature. We'll roll out in January at some point. So thanks.
Yeah, to touch on that, is that going to be able to be used with BPSs? Because I see a bunch of people just totally exploiting that.
What do you mean exploiting that? Like a lot of pools run VPSs.
So, could you re-explain that? Are you saying that anybody without the staking power is able to just acquire staking power now and then get rewarded with it? Right.
No. Let me make sure it's clear. So right now, let's say we want Satori to be as distributed as possible. And so somebody that comes and says, "Hey, I'd love to participate in Satori, but I don't have enough to I do have a computer, but I don't have enough to like get the staking requirement, but I'd love to participate. Like, what can I do?" The answer right now is nothing. Go away. And so we don't want that to be the answer. So what we want to be able to say instead is, okay, you don't have this staking power, but you do have a computer. So turn Satori on your computer. We'll handle everything in the back end. But basically, your neuron will say, I would love to participate in Satori. I'm making predictions. If anybody wants to give me staking power, those predictions will be counted, and they'll whatever. So they'll be rewarded, and then those rewards go back to the pool, just like they do on the other side of the equation. They go back to the pool, and the pool is responsible for rewarding the workers that they have assigned to them. Does that kind of make sense? So it's exactly the same thing right now. We say, well, if I don't have a computer, I don't want to use it for this, but I do have some Satori, then I can join a pool. And the pool at this moment in time needs to run their own workers, which means they need to spin up VPSs or whatever. And that's not ideal because there's all this idle compute power. Like, if somebody's willing to run this on their laptop, it's got 16 cores, it's running all day. You can make much better models than you can on a single core VPS by using that laptop. So let's make that laptop available to the pool operators. I hope that this is clear enough. Maybe I shouldn't have said anything and kind of organized it into an announcement so it's clear. But anyway, any questions on that? If there's some clarity lacking.
I the neuron staking to bad guy's pool. Can I turn that into a worker and stake it to his pool?
Can you turn what into a worker? Sorry.
The neuron that's staking.
If it's already staking, then no, it won't be. It won't be in the in any pool because it's already staking its own token. So it would only be neurons that don't have enough stake to for the staking requirement.
So essentially, you're creating a Satori pool, a Satori run pool, is what I'm getting at. Because that's how pools run right now, Meta, is that if you don't have enough staking power, which many users don't, they join a pool and they still get rewarded.
Right. The pools they aggregate staking power right now. So they aggregate staking power up to the pool, and then they distribute it back down to workers. And then the workers make predictions, and the workers are the ones that earn the token, but those rewards go back to the pool, which says, okay, I only earned all these tokens because of all these participants that lent staking power. And so then they distribute it back down to the stakers. And that's only one half of the equation. It's the staking power equation. The other side of the equation are the workers, and they're spinning up all those workers themselves. And so this new update says, if anybody without any staking power, no Satori, wants to be a worker, they can use this feature to get assigned to a pool, so that the pools have higher quality computation, first of all, and that anybody can participate in the network again. And that's kind of the goal of the decentralized aspect of it. The Satori Association's main focus is always to make the network as decentralized. It's to make it into a DAO. So that's kind of the main point of that.
Understood. So I see what you're saying. You're trying to gain more computational power this way because essentially pools are just spinning up a whole bunch of shitty VPSs and running neurons off that, which they could be better run with a household laptop or whatever else. But what I'm trying to get at is that could it be possible for someone who's, a whale to jump in with a bunch of VPSs that say 4-core whatever and just say run those in with zero staking and then somehow generate Satori and then dominate more of the market?
There's really not a way for that to happen. If there's more compute power than the staking can utilize, then the extra compute power just doesn't get utilized. I mean, the predictions, they get broadcast out and you can listen to them. Actually, they provide that value, but they don't get scored. They don't get rewarded. There's no incentive to do extra to provide extra computational power, because it won't just get rewarded ad infinitum. So I hope that kind of clears that up.
Thank you for clarifying. Appreciate that.
Yeah.
Also, great work so far. I appreciate it.
Thank you. Okay, let me just read through these notes real quick, and I think that might be the end of the questions. And pig, yes, yeah. I think you've got it right. One difference I've noticed, those that come from a traditional background kind of see the Satori system and they assume certain things. They assume that it's kind of a centralized master that is distributing jobs down to workers and then aggregating those jobs back and building this massive model in-house. That's not exactly the design. The network, the nodes are all autonomous. They're all doing their own thing. There's not one controller. They all build their own models. They keep them on their own. So there's a lot of difference there, but the basic idea of distributing the computational workload across the network is the case. So yes. Okay, if there's any more questions or comments or anything, otherwise we'll probably close it down. Thank you guys for coming on, and we have some other plans. We're thinking of doing one that's about not necessarily Satori immediately related, but about the environment of decentralized identity. I know we have a couple experts in our network, and hopefully we can get them to do a presentation next quarter on decentralized identity. I think that would be really cool. So we're gonna keep these going, and we'll have a new topic every quarter, and of course we'll do other things as well. But thanks again for coming, everybody.
Right on. Thank you. Have a good night, everyone.
Here, I'm going to tell you about what Satori is. Satori is a blockchain that predicts the future. It watches the world and predicts how it will evolve. Those predictions are free and open for everyone. They cannot be censored. That's why it uses blockchain. Satori has a machine learning engine. It's automated and learns how to forecast the future. That's how the predictions are made, through the use of AI. Satori lives at the intersection of blockchain technology and artificial intelligence. It is a blockchain that predicts the future. Now, next let's discuss how Satori works. Satori is a network of computers, each of which is a Satori node. When a Satori node starts up, the network assigns it something to watch, something to predict, something to become an expert at. The Satori node then subscribes and watches that piece of information, whether it be a government statistic, stock price, climate metric, or something else. As it watches the data, it learns how this thing, whatever it is, reacts to all other changes in the world. It finds correlations, detects patterns, and in general makes better and better models of what the future will be. The Satori node never sleeps. It runs all the time, broadcasting its best estimate for what the future holds. It even works with other Satori nodes to discover things it couldn't on its own. Over time, it becomes an expert on the topics it was assigned. And it never stops learning. That's the key to how Satori works. Every Satori node watches some real-world data, specializes in understanding it, and works all day, every day to make the best predictions it can. All right now, just how will Satori be developed? Well, that's what we're going to talk about next. Satori's development has 3 planned phases. 1. Produce the public good. 2. Build the prediction market platform. 3. Make it a DAO, distributed autonomous organization. The first phase, the public good, is Satori's primary objective, free and open knowledge of the future. This phase begins with initial conception, research and design, and completes once the network is of a sufficient size to watch and predict the future of all popular, commonly valuable world metrics. In other words, Satori provides the public service, first and foremost, of predicting everything that everyone finds valuable. It does not charge for this service. Anyone in the world can visit the Satori search engine and see what Satori believes the future of any public metric will be. After the network has scaled enough to produce an adequate public good on an ongoing basis, it'll be ready to implement Phase 2. Phase 2, the prediction market platform, allows anyone to get specific, highly informed, unbiased predictions from the Satori network. The Satori prediction market, running on the Satori blockchain, is a platform that will bring consumers and producers of prediction together. Anyone will be able to leverage the wisdom of the Satori network. For example, companies will be able to anonymize their data and contract with the Satori network to get unbiased predictions of future changes in their data. Even individuals will be able to, say, ask the Satori network to track their biometric data captured by their smartwatch and give them real-time warnings or help them progress towards their goal. Phase 2 represents the second layer of Satori, making all the specialized models and computerized expertise that has been developed in service to the Satori public good available to the world. Once the Satori prediction market is completed, allowing consumers of prediction to contract with Satori nodes, Satori will enter the third and final phase of its development, becoming a fully decentralized, distributed autonomous organization. Satori will initially launch, as so many blockchain projects do, as a pseudo-decentralized system, one that starts with centralizing training wheels and has the ability to evolve into a DAO eventually. This is because building a pure DAO is often a very hard problem. Without a centralized authority, they are prone to to misaligned incentive structures and numerous attack vectors. Fortunately, many challenges decentralized systems face can be mitigated by scale and may be altogether solved with future communication technology. During Phase 1 and 2, some of these training wheels will be removed. The goal of Phase 3 is to remove any and all remaining centralized force or authority, because it is important for prediction to be as unbiased as possible. Prediction of the future, like news of the past, should be decentralized and uncensorable. Any manipulation of predictions of the future represents some special interest's control over that future. Once Satori achieves the status of fully decentralized distributed autonomous organization, it will not just be a DAO. Since it uses AI technology, watches and predicts, and therefore affects the world and manages its own attention, Satori will most likely be the world's first distributed autonomous machine intelligence also. Finally, if you'd like to get involved or in some way participate, well, I'm going to tell you just how to do that. If you want to see the predictions that Satori produces, you can visit satorinet.io and use the Satori search engine. If you want to run a Satori node on your machine, just follow the install instructions at satorinet.io. The Satori node is fully automated and is easy to set up. It will mine Satori tokens as it makes valuable predictions, so try to keep it running as much as you can. Remember, all of the expertise it develops, all of the models it creates are yours and will stay on your machine. On the other hand, if you just want to learn more, you can visit satorinet.io, where you can find the white paper and source code and links to Satori's social media and chat platforms. Thank you for your attention. Namaste.